Hi, I'm Alex from the Zscaler Customer Success and Engineering team. In this series of short videos, we're taking a look at the baseline recommendations for the configuration of data protection inside Zscaler Internet Access. This is part 1, Understanding Data Protection. Before we start talking about data protection and how to configure it, it's important to understand what's at stake. First, it's important to know that data today is everywhere in devices, clouds, and locations. Protecting data can therefore be a huge problem, especially because often multiple data protection products are involved, with fragmented policies, excessive alerting, siloed visibility, and slow response from the teams that are responsible for making sure your data is secure. Loss of sensitive data is a real issue for organizations today. The average cost of a breach is $4.5 million. Most breaches are caused by a combination of bad actors with targeted exfiltration and ransomware, careless users accidentally exposing data from oversharing, malicious users, for example, users committing intentional theft or departing employees, or misconfigurations in cloud applications which create exploitable openings in your posture. This is why, in order to build a data protection strategy that comprehensively protects your data and your users, you have to build not just a set of data protection policies, but a comprehensive data protection program. Next, let's take a look at how Zscaler's data protection platform functions. First, it's important to understand that in order to apply data protection policies, Zscaler has to have visibility into the data, which means there's a requirement to SSL inspect transactions for any traffic that you want to apply data protection policy to. Without that visibility, we're not able to apply those policies. Once we have that visibility, the first step of building a data protection policy is to discover your cloud applications. Since your user's traffic is going through ZIA, we have full visibility of all the cloud applications that the end users are accessing, and we're able to identify those cloud applications and index them inside a dashboard that's visible to you inside the administration UI. This also allows us to discover and secure data flows. So the data flows generated by users, traffic to the internet, to applications, etc., can also be discovered, identified, and secured with policies like cloud application control, tenant restrictions, and others. This makes up the inline data loss prevention part of a data protection policy. Then we have data at rest. This is data that's not in transit between your users and the internet, but is simply resting inside, for example, a SharePoint tenant. Here, Zscaler provides API integration with those tenants, which allow you to verify if there are any DLP policy violations or malware risks for that tenant based on a DLP policy that's been configured. This simply scans the tenant and then reports or applies, depending on your configuration, the DLP policy that you want. Posture is also something that we can verify for SaaS applications. We're able to scan tenant configurations and check them for any misalignments with several security frameworks. For example, is multi-factor authentication enabled, etc., etc. This will allow you to identify and remediate misconfigurations inside SaaS tenants, which may themselves be a security risk or a data loss risk. Next, we're also able to secure email data from outgoing emails from Microsoft Exchange and Gmail. And finally, we have the ability to secure endpoint channels, for example, USB drives, network shares of printers. All of those can also be protected via the client connector. Finally, before I finish this video, I want to spend a little bit of time talking about some common misconfigurations we see for SSL inspection policy, since it's such a crucial part and prerequisite to being able to configure a data protection policy. Remember, if SSL inspection isn't configured for traffic, we're unable to see inside that traffic, and therefore we can't see the data and apply data protection policy. The first of these misconfigurations is that often we find that OneDrive, SharePoint, and Microsoft login services have not been inspected. If you've enabled the Office 365 one-click policy inside Zscaler, this means we've applied a policy per Microsoft recommendations that exempts that traffic from inspection. However, in order to be able to configure a policy for SharePoint, OneDrive, and other Microsoft services for data protection, it's important that that traffic not be exempted from inspection. To make sure this traffic is inspected, you simply need to create a policy above the Office 365 one-click policy that is configured to inspect the SharePoint, OneDrive, etc. cloud applications. For more details on this, please refer to our video series on SSL inspection. Next, it's common to see that wildcard bypasses have been added to SSL exemption lists. This is when you enter an entire domain inside the list in the form of a .domain.com entry. This is useful when configuring bypasses, since you don't need to know exactly which subdomains in a domain are performing e.g. certificate pinning and need to be exempted. Unfortunately, by doing this, you expose yourself to a great deal of risk. Since you've exempted every subdomain and every destination under a specific domain, it's entirely possible that subdomains or destinations under that domain need to be inspected, both for malware prevention reasons and in order to secure data being sent to those websites. As such, it's recommended that you make sure that you are exempting only specific FQDNs inside your exemption list, and that you have built an SSL policy that inspects all traffic by default. Again, we recommend referring to our video series on SSL inspection policy in order to understand how to best configure this. On a similar note, it's especially important that you make sure that AWS and Azure are not bypassed at a wildcard level. It's fine to bypass specific Azure blob storage or S3 bucket destinations if those are required for specific applications to function, but you should not be bypassing .windows.net or .amazonaws.com wildcards from SSL inspection, as this will result in all destinations under Azure or AWS being exempted. Since so many applications use S3 buckets or Azure blob storage in order to store data, exempting these domains from inspection will result in a greatly diminished ability to apply a data protection policy to your traffic. With that said, that's it for this video. Thank you for watching.